welcome back. We want to keep talking about systems of linear equations. I have real tiny over here on the right, the steps for solving a system. Basically what you're doing is working with two equations at a time, and you're attempting to eliminate the same variable both times. Okay? Then you're going to take those two equations and eliminate another variable, and there you will have a variable solved, and then you use back substitution to solve. Now notice this one looks a little bit odd, doesn't it? The spacing is weird. You know why? Because the first equation is missing a y. Hey, let that be a help to you. If the first equation is missing a y, why don't we just work with the next two equations and eliminate y there? If we can get rid of this y right here, then we will use the first equation and the equation where we eliminated a y using the addition method, and we'll have two equations we can solve. So if you're missing a variable, then work with the other two equations and get rid of that same variable. That's a good trick. Now put that little curly brace there, and we don't need that. Hey, let's just focus on the second two equations and get rid of y. Now, this is the big question. What do we need to do to both equations or either equation to get rid of a y value? Well, if you notice, I got a positive 2y here and a negative y here. If that were a negative 2y in the third row there, we'd have it, right? So what am I going to do? It's already negative. I'm going to multiply everything, not just that y, but everything by 2. Then I'm going to rewrite these equations and work with them. So I've got x plus 2y minus z is equal to 1. Second equation, I didn't do a thing to it. Multiplying the third equation by 2. So 2 times 2x is 4x. 2 times negative y is negative 2y. 2 times z is plus 2z. And don't forget, 2 times the constant 3 in this case is 6. And there we go. I add down, I eliminate my y's, because when you add down it's 0y. X plus 4x is 5x. Negative z plus 2z is plus z equals 1 plus 6 is 7. So now I have an equation here that has no y in it. And my first equation up here also has no y in it. And I work with those two together. So let's write it down. So x plus z is equal to 3. You don't have to put that big old space in it. 5x plus z is equal to 7. Now, if I add down right now, nothing cancels, right? So what could I do? Got options. I could multiply the first equation by negative 1. It would make that z negative. Added to that positive z, my z's would be gone. Or I could multiply the first equation by negative 5. It would make that x a negative 5, and that positive 5x would add, and that would disappear as well. So I'm going to focus on the z's because it's just easier for me to think about. So multiply that entire equation by negative 1. Then what I'm going to do, I'm going to rewrite it all. Now, a lot of y'all try to do this without writing so much. I didn't even multiply. Thinking ahead, and then I can't do my math at the same time. Let's try it again. Negative 1 times x is negative x. Negative 1 times z is negative z. And don't forget, negative 1 times 3 is negative 3. And then we have 5x plus z is equal to 7. The second equation I didn't do anything to. Negative z, positive z cancels. Negative x plus 5x is 4x. And then on the other side, negative 3 plus 7 is 4. Hey, divide both sides by 4, and I get x is 1. So we have a solution right there. Now what am I going to do with that? If I go back and take it and plug it in one of the originals, I might have trouble because I've got two other unknowns. Except in this fancy case, I can plug it in either this value right here, that in the middle equation, or I can go back to the first equation because it doesn't have a y anyway. Let's go to the first one, okay? So I got 1 plus z is equal to 3. Now I just subtract 1 from both sides, and hey, I find out z is equal to 2. Circle that sucker so I can find it later. Now I have two variables. I know what x is, I know what z is, and now I'm just trying to find y. Now I can't use my first equation to find y, right, because it has no y. So I'm going to move on to the second equation. So I know x plus 2y, I'm going to write it down, minus z is equal to 1. Then I'm going to plug in what I know. I know x is 1 plus 2 times y, I don't know, minus z is 2 equals to 1. 1 minus 2 is negative 1. So 2y minus 1 is equal to 1. I add 1 to both sides to get 2y is equal to 2. And it turns out that y is also equal to 1. So I'll write this as an ordered pair. I'm going to stick with my habit and make it in bright red. So 1 for x, 1 for y, and z is always last, which is 2. But you know what? I'm not going to type this into my homework or into the test or anywhere until I check my work. Now I'm going to check my work in my head because I'm lacking space. You have paper at your house. You can write this down on paper. You should do this. So I'm doing 1 for x plus 2 for z. 1 plus 2 is 3. First equation checks. Now I'm going to do 1 for x plus 2 times 1 is y. That's 3. Minus 2 for z. 3 minus 2 is 1. That checks. Third equation. 2 times 1 is 2. Minus 1 is 1. Plus 2 is 3. That one checks too. And again, don't do like I did. Don't do that in your head. Do it on a piece of paper. Check it. Make sure it's right. And then you're confident when you type in your answer. Alright, so example E here. I think you should pause it and try this one on your own. Now you got to kind of think about what you're doing. Notice each equation is missing a variable. But come up with a plan in your head that seems to make sense and see if it'll work out as you do the problem. So pause it, see what you find out. You're back, right? How'd it go? It was fast, right? Anyway, okay, let's do it together if you didn't do it on your own. If you did do it on your own, pause it now and do it on your own. But otherwise, let's work together. So, first two equations, right? What if I get the x's to cancel? I'm left with y and z. Hey, my third equation has y and z. So we can use the eliminated first equation and the third equation to solve. So let's work with the first two. Now, if I work with the first two, then I can only get the x's to cancel because that's the only thing they have in common. They don't have a y and z in common. Okay, so I'm going to multiply the first equation by negative 1, y, so I could get the x's to be opposite coefficient signs. So that's going to give me negative x minus y equals negative 4. Everything by negative 1. Second equation, I'm just going to recopy. X plus z is equal to positive 4. Okay, the x's cancel. Now, I can't really add negative y plus z, but I can write that down. Negative y plus z is equal to 0, right? Negative 4 plus 4 is 0. Is that okay to do? Yes, it is. Okay, so this is one of my equations. Now, I'm going to work with the third equation. So now I have y plus z, third equation, is equal to 4. And this guy right here, negative y plus z is equal to 0. How easy is this problem? Look, those cancel. No work to even do, they just cancel. And now I've got 2z. Remember, there are 1 coefficients in front of both of those. So 1z plus 1z is 2z. 4 plus 0 is 4. Divide both sides by 2, and I've got z is equal to 2. Yay! Now z is equal to 2. I can go back to any of those equations and find what I'm looking for. So, well, no, I can't. I can't go to the first equation. Why not? Because there's no z in it, right? That's not going to help me at all. But I can go to the second equation. X plus z is equal to 4. And I'm going to plug in 2 for my z value right there. So x plus 2 is equal to 4. Subtract the 2 on both sides, and I get x is equal to 2. Now I've got 2 of my variables. What am I going to do to find the third one? Well, I need something with a y in it. Okay, so the first equation will work, or the third equation will work, just not the second because it doesn't have a y. So x, I'm just going to write the first equation down so you can see it. X plus y equals 4. And I know x is 2, so 2 plus y is equal to 4. Subtract 2 on both sides and get y is equal to 2. Well, how fun is that? So I have the result that x is 2. I'm not doing it in red. Y is 2. And z is 2. Should I check it? Of course I should, right? So x plus y, 2 plus 2 is 4, that checks out. X plus z, 2 plus 2 is 4, that checks out. Y plus z, 2 plus 2 is 4, that checks out. You might be looking at it and going, I could have done that in my head. Well, maybe you could, maybe you couldn't, but you need to do it on paper just to be sure everything is going right, okay? All right, let's try another one. All right, what do we have here? Example F, find the quadratic function y is equal to ax squared plus bx plus c whose graph passes through the given points. Oh, wow. So they gave us points on a parabola, right? Because a quadratic function graphs a parabola. So these are just points on xy values on a parabola. And they want us to find the a and the b and the c so that these points will land on that parabola. Sounds kind of nightmarish, doesn't it? It's not that bad. Really, it's not. It says to solve this problem, think about 3 quadratic equations with the given x and y values. They gave us x and y values. Substitute it in. That's your system that you want to solve for a, b, and c. So let's try it. So I'm going to use, first of all, I'm going to use negative 2, 7 right here and plug it in to y is equal to ax squared plus bx plus c. What do you mean plug it in? My x is negative 2 and my y is 7. So I'm just going to plug that right in. So I have 7 is equal to a times negative 2 squared plus b times negative 2 plus c. Okay, so that gives me the equation. I'm going to come over to the right here. I'm going to write with the constant on the other side too because it looks better. 4a, that came from negative 2 squared is 4a, minus 2b plus c is equal to 7. That's the first equation in my system. What am I going to do now? I'm going to move on to, this is my x and this is my y, and again plugging it right back into there. Okay, just like we did the first time. So this time my y is negative 2 is equal to a times 1 squared plus b times 1 plus c. Okay, now I'm going to flip it around on you. So 1 squared is 1, that's 1a, or just a if you like. That's 1b, or just b, plus c, which really is 1c, equals negative 2. That's my second equation. Third equation, you know the drill. Could just fast forward and do that. So I'm going to plug in x is 2, y is 3, back into this quadratic function form. Okay, so I've got 3 is equal, because that's my y value, and I have a times 2 squared plus b times 2 plus c. I'm going to make it look a little better by saying this is 4a, because I want to square that 2, plus 2b plus c is equal to 3. This is my system. Now what do I do with that? The same thing that I did earlier is I'm just trying to eliminate the same variable. It's going to take more than one page to pull this off for sure. So you have to just bear with me to get this done. Go ahead and be thinking about what variable you want to eliminate out of the first two. And then we'll eliminate that same thing out of the third equation in one of the other two. And that will give us 2 equations that we can work on that system. And then we'll start back substituting. Okay? So if I'm working with the first 2 equations, and let's just say, let's get our b's to cancel. Let's do something different. Instead of doing the a's, which we were always doing the x's, let's focus on these b's right here. How can I do that? Well, if I multiply the second equation, everything in it, by 2, that's going to make that a 2b added to that negative 2b, and poof, my b's are gone. Okay, so I'm going to write that over here. I'm going to try to write smaller and neater, and let's do it in black so it's not all blending together. So I've got 4a minus 2b plus c is equal to 7. Second equation is 2a, because I'm multiplying by 2, remember, plus 2b plus 2c is equal to negative 4. And I add down. 4a plus 2a is 6a. This is the addition method or the elimination method, whatever you like better. plus 3c is equal to 7, and negative 4 adds to be 3. Okay, so that's one of my equations. 6a plus 3c is equal to 3. All right, now I'm going to erase some of my scratch work here. I'm going to try. There we go. Okay, now I'm going to work. I've got to work with the third equation because I haven't worked with it yet. I also have to cancel my b's. Okay, so you know what I'm going to do? I think I'm going to work. Oh, no. Let's work with the first equation and the third. Why? Because look, the b's are already opposite. Isn't that great? Okay, so I'm just going to stack them up. 4a minus 2b plus c is equal to 7. And then the third equation, 4a plus 2b plus c is equal to 3. All right, so I add down, b's cancel. And now I've got 8a plus 2c, because I added 1c plus 1c, that's 2c, is equal to 7 plus 3 is 10. Now I have a second equation that I could work with. Okay, so we've got a little bit of room. We can work on this page. Now, remember, I'm going to stack these up. 6a plus 3c equals 3, and 8a plus 2c equals 10. Would you like to cancel out the a's or the c's? It doesn't matter to me. I'm thinking c's just because those numbers are smaller. How would we do that? Well, I have to have those coefficients opposite, right? What if I multiply the first one by negative 2 and the second one by 3? Why would I do that? Excuse me. 3c times negative 2 is negative 6c. 2c times 3 is 6c. That would make my c's cancel out. So here we go again. I'm going to write this as negative 2 times all of these. So negative 12a minus 6c is equal to negative 6. This equation here, everything times 3. 24a plus 6c is equal to 30. So you got to develop a plan. Some of it's as you go along. You don't have to think way far ahead. But remember, you know, you're trying to get things to eliminate. And when in the very beginning, it needs to be the same variable that you eliminate. So I add down right here. That's going to give me 12a. C's, of course, cancel. Other side, negative 6 plus 30 is 24. And I like that a lot because when I divide both sides by 12, that gives me a is equal to 2. And I built myself a new page to put all this scratch work on, but you know what? I don't have to, if you don't mind me writing all over the place. So I've got a equals 2. Now, what do I do next? Don't go back to your original 3 equations, which, by the way, are over here on the right. I'm going to read them off. Those are my original equations right there. Okay? So I'm going to go, I can't plug a equals 2 in any of these because I still have a b and c missing, but you know what I can do? I can plug in a equals 2 into either of these. I'm just going to go with this first one over here, the 6a one. Go to the top of the screen here and say 6. My a is 2 plus 3c is equal to 3. So that gives me 12 plus 3c is equal to 3. Divide by 12. No, subtract 12. Hello. So 3c is equal to 3 minus 12, we know is negative 9. I divide both sides by 3, and I get c is equal to negative 3. I'm going to circle that so I can find it in a minute. Hey, now I have 2 of my variables. I've got a equals 2 and c is equal to negative 3. Matter of fact, I'm a little nervous about that. I'm checking that calculation again quickly because I just tried to really mess it up. I think you're okay. Okay, so now I'm going to take a equals 2 and c equals negative 3 and plug it in either of these 3 equations right here. It does not matter which one you plug it into. Okay, I'm going to plug in the first one. Actually, the second one is way easier to work with. You see that? Look, that would be much easier to work with. So as a is equal to 2, so I have 1 times 2 plus 1 times c is equal to, I don't know, b, So 1 times b plus c is equal to negative 3 is equal to negative 2. Okay? So I add 2 plus negative 3. This gives me negative 1, which is b minus 1 equals negative 2. I add 1 to both sides. I get b is equal to negative 1. Okay? Now I have my system. A is 2, b is negative 1, c is negative 3. In green, y'all, this may be how you have to type it in your homework. They want to know the function. That's right here. So we know y is equal to a, which is 2, that's my x squared coefficient, plus b, which is negative 1, that's my x coefficient. I'm going to write it as minus x, plus c is negative 3, minus 3. That is my quadratic function, if I didn't make any silly mistakes. Now, what I didn't do is I didn't check my work. Now, how do you check it? You take your a, b, and c and plug it back into that system that we built. So 4 times 2 is 8. Plus 2 is 10, minus 3 is 7. So it checks in the first equation. I know it checks in the second equation, I'm pretty sure, because that's the one I use. So let's check the third equation. 4 times 2 is 8, plus 2 times negative 1 would be 6, after I added it to that 8, and then plus a negative 3, 6 plus a negative 3 is 3. Yes, so I took my a, my b, my c, and I plugged it right back into this quadratic equation. Those are fun, aren't they? I knew you would like it. Hey, you know what? I'm going to come back for part 3 for this. So I have 2 application problems. So you're good to go in the homework for the methods as far as solving the systems, but I've got this word problem, and then I've got one more word problem involving a triangle that I'll come back and do a part 3. How's that sound? Hope you have a great day.